So again, we're looking at squares, and this time we're looking at a difference of squares. These things are really important to remember the names because they've done studies. If you remember the name of something, you usually remember how to do it better, as opposed to someone who's like, I've never heard of difference of squares. And then I say, oh, can you factor this? And they're like, no. But if you remember the name of something, it triggers your brain also into remembering how to do that. So we don't only learn the math when we're learning something, we're also learning the terms to describe it, because that's going to help us remember how to do it. So, squares. You should know what a square is. And here are our perfect square numbers all the way up to 12. Am I missing one in there?
Yeah.
Which one?
4.
4 squared. Nice. Good eye, good eye. Any other ones?
Nope.
No? Okay. You know what I just did there? I tricked you guys into doing mental math, right? Right? You guys just did a bunch of mental math by checking your squares, finding out that 4 times 4 was missing. Perfect. So you can recognize a difference of squares when there's only 2 terms, both which are squares, and difference means subtract, so there'll be subtraction.
Can I go get tape for my finger?
Tape for your
Yeah,
fingers.
it's like
Falling off?
Oh, what the hell?
I examined it yesterday.
How?
Gym class. Marley.
No, it's gonna fall off.
Yeah, you know it's getting like
Person that
it's gonna fall.
Yeah, that's what I'm saying. Oh, yeah.
There you go.
There's no way.
Okay.
Hair on it.
Yeah, but I mentioned.
So, here's an example of differences of squares. And something very pretty happens when we factor differences of squares.
Look at how small it is.
They will be like trinomial factoring, but you need something to happen so that your first one still gives you this, your last one still gives you that, but your outside and inside disappear. That's the Halloween, right? That was good, right? That was a good little bit of Halloween theme in there. The outside and the inside.
What is that word?
You're not even paying attention. Okay. Would you agree to get an x squared that you would need an x and an x? And to get a 4, we have options. It could be 2 and 2, it could be 4 and 1, but I need my outside and my inside to disappear.
Plus 2 and
Plus 2 and minus 2. Do you see how that works?
No.
If you multiplied it out, technically you would get x squared plus 0 x's minus 4, but we never write 0 x's, we just don't write it. Does it make sense that if your outside and inside are the same, but one is positive and one is negative, that it would always disappear? So if I have x squared minus 21, it could be x and x, 11 and 11, and one is positive and one is negative. That would go away.
Oh. And the next one's 6.
So technically, we are factoring trinomials just like before, but the 0 is there. And we don't really call it a trinomial with a 0 there, because a trinomial means 3 terms, and technically we only have 2 terms. But one of them is a 0, so this is the same kind of factoring we've done before, but we have to recognize it as it's a difference of 2 squares. This is the special kind of trinomial factoring, which is really always the same. Your outside and inside have to disappear as a result, So one has to be positive, one has to be negative.
Oh
It's easy.
You weren't done.
It doesn't matter which
Can
side
I have my
positive,
ear
which
tape
is
back?
negative because they're the same, right?
This is for
Oh, yeah, that has a lot of
earrings in their ears. So I have to take them up.
Wait, would it matter which side is positive and which is negative?
No, it doesn't. You can have it minus and plus or plus and minus.
It's not.
That's what it's supposed to equal. Because
So,
the x's cancel it out.
When you multiply it out, you would get 0 x's because your outside is 2x or minus 2x and my inside is plus 2x. They would disappear. Okay. The next one, is this a difference of squares? Is this a perfect square? Yes, it is. 3x and 3x, 144 is 12 and 12, okay, is plus and minus. You could do that, but this isn't the right answer completely.
Oh, you keep
Well, 'cause
going.
you can factor it more or whatever.
Because you could factor out common things. So let's say we did this, well, obviously we did do this first. We did this first, but now we look at the first term and say, there's a 3 in common. I could pull out a 3 out of that and be left with x plus 4. There's a 3 in common in this one. I could pull out a 3 and be left with x minus 4. Putting this together, 3 times 3, that's 9. So what happened in our case? If we look at our factoring steps, difference of squares we listed last because we hadn't even done it yet. We noticed that first and did that first. But what we could have noticed is number 1. This one has a greatest common factor. So I'm going to redo this and say, if you also noticed, you could take a 9 out of 144, which you might not see, right? If I pull a 9 out, 9 times 16 is 144. And I think this is a great example of where you probably might miss that. Right, your 16 times table, right? Maybe not the best. But if I did see the 9 first, can you see that I still am left with the difference of squares inside? X squared minus 16 would give me x and x, 4 and 4, 1 plus, 1 minus. Both the green method and the blue method are the same, and both are right. We usually do say, find the greatest common factor first if you can. Okay? So the recommended method would be the blue method.
Why do you keep going after x squared minus 16?
Oh, he's breaking.
Because this is the difference of squares.
Oh,
X squared is a squared, 16 is a square, so I can do the difference of square factoring at the end there. So the blue method is the recommended method, but I think in this example, you might see the green method first. Okay? And that's not wrong. But then you still have to check, is there common factors? Did I miss something? And then I looked at my 3x plus 12, and I'm like, oh, I could pull out a 3. And I look at my 3x minus 12, and I say I could pull out a 3. And so I'm left with the same answer, 2 different ways to get there. And as we get to more and more complicated math, that's usually the case. There starts to be more than one way that you can solve a problem. And there's not a wrong way. There are sometimes recommended ways. Okay, like the blue is the recommended way, but in this one, I actually like the green better, even though I recommended the blue. So it's nice to see those, that sometimes a non-recommended way might be better in special situations. Right? Like if I see, initially I see that those are both perfect squares, I'm not going to spend time looking for a common factor. I'm going to go, just like we did in the green before, I'm gonna go bracket, bracket. This is 5x and 5x. It's a difference of squares. This is 7y and 7y. One's plus, one's minus. And then I check them and say, are there any common factors in the green brackets? In this case, there's not. So I saved myself some time by just going with the method I felt to begin with would work and checking it afterwards. But that is an important math skill to always have. Do some work, check to see if you notice anything. Do some more work, check to see if you notice anything. That process is going to help you out a lot as you do your math. So, I run into a dilemma. I run into a dilemma with the third one. Because I see that this 100 is a perfect square and the 64 is a perfect square. So I know right away that I have a perfect square difference of squares. I also see right away I can divide both of them by 2. So I know that there's a common factor. So now I'm trying to decide, should I do what we did in the top one, the green method first and factor after, or should I find the greatest common factor? Or should I just do them both?
Because if they're both perfect squares, then wouldn't you just do the same thing and do the 25 and the 49?
So you're saying go with the green method?
Yeah.
In the top one? Okay. So if I go with the green method,
10a plus 2.
I have 10a, 10a, and 8b, 8b.
Plus
Wow.
and then minus.
1 plus, 1 minus. And then I have to check each of those for common factors. Is there something common?
2.
2. So I pull that 2 out, leaving me with 5a plus 4b. And I can also pull a 2 out of this one, leaving me with 5a minus 4b. And 2 times 2.
So if you didn't do the 4 part, would you lose a mark?
Yeah, because it's not simplified. This two numbers that are all on their own like that can always be put together and multiplied. So that would be considered simplified. Yes.
Using the blue method, you can pull out a 4 from the beginning.
Right. So using the blue method is if you can pull out a 2 and these are perfect squares, it means you could also pull out a 4. So if you pulled out a 4, leaving you with 25a squared minus 16b squared, and then factored it to 5a plus 4b and 5a minus 4b, that would work as well. So both methods are good. Ask yourself, mental math-wise, if you see that a 2 can be pulled out, and 2 isn't a perfect square, can you see that 4 had to be able to be pulled out? Because if it was perfect squares to begin with, and you were pulling out something, you have to pull out a perfect square in order to keep perfect squares inside. That's a lot of the word perfect squares in one sentence. 5 is not a perfect square.
But you can do the simplified first, so
Yeah.
1, so x squared minus 100.
So if I take the 5 out, because I know that it's in common, then what's left is a perfect square. X plus 10, x minus 10.
Wait.
Question?
Don't you have to do a 5 in the middle as well?
No. 5 in the middle here? That would mean I could pull out a 25. There's not a 25 in it. I look at the beginning, and then when you have this, this is equal to that. Every line that you write has to be equal to what was above it. 5 is equal to 5. This is like, this matches up. And now the purple I've replaced with that. They equal each other. That matches up. Can't add another 5 in there because then all of a sudden it's like, where did that 5 come from? It didn't exist in the previous line. And grade 10 math teacher favorite is factoring x to the 4 minus 1. See if you can figure out why it's a grade 10 math teacher favorite. Not just this grade 10 math teacher. everywhere you see this question, grade 10 math. Figure out what's different about this one than the other one.
See,
Yeah, I think I wanna do
I don't see.
X squared plus squared.
It is very easy to not make a mistake on this question, but lose marks. Does that sound confusing?
Yes.
Because X squared
Oh, Eisen sees it.
X squared plus one
Yeah, I don't see it.
X squared
Yeah, I don't
minus
see it.
one word.
It's probably because you haven't made a mistake yet.
is it
But you
X,
still
X,
lose
X, X?
Okay, let's. Did you do this? Oh, it's a difference of squares. X squared,
Yeah.
1 and 1,
Yep.
plus and minus.
Yeah.
There's no problem.
There's no problem. You've made no mistakes, and you would lose marks.
Why?
Oh my god.
So we can make mistakes.
Because you're not done.
No, we pull out.
Because this makes a new difference of squares.
I don't know.
Watch. I can rewrite this one because it's the same, but this one, what makes x squared? X and x.
Oh,
And 1 and 1 and plus
What?
and minus.
Wait, I was right. Wait, cause
So there's nothing wrong with the first step. You didn't make a mistake. You just never finished the question.
What would you still get?
Wait, what happened there?
You would get, so this part here underlined in green is another, difference of squares.
wait, then wouldn't it be X plus 4 times?
No, because this one, you cannot factor because it's not a difference.
Then if it was plus one and plus one, then it wouldn't get.
It would get plus 2x when you do your outside and inside. So that's tempting, right? It's tempting, and I'll do it in red here to show how tempting that would be, right?
Mhm.
But when you FOIL this out, you get x squared plus 2x plus 1, perfect square trinomial, and there's no 2x in the middle there. So this is why this doesn't work, and this one cannot be factored any further. You want to see crazy?
Yeah.
You want to see crazy?
Yeah.
How crazy? Just a little crazy? Or a lot crazy?
A lot.
I'll do a little crazy first. Okay, a little crazy would be this one. Why is this a little crazy? Because
There's a lot of stuff.
this would be x4 plus 1 minus 1.
Then X
And then
4 plus 1
this one's done, but this one,
squared
X.
minus plus 1 and
Then
minus
what
1.
is your food again?
And then
There, the one's for
X to the 4 plus 1, X plus 1, X minus 1, X plus 1, X minus 1.
done.
Oh, so you just, why don't you make like the first
I might as well just leave now.
Nope.
It's over.
like the
How crazy you want to get? Have you ever played that game 2056? Have you ever played that game? With boxes? Oh, sure. It's awesome.
Sure. Sure, come here. Come say hi.
Quit distracting them. Yeah, well,
Sure.
you did.
This is the fan favorite right here.
Hey, love you though. All right.
Yeah, we love you too.
Well, that's all in the video. That's just like
And that's heartwarming.
heartwarming. We thought this was going to be a scary Halloween lesson, and it turned into a heartwarming,
It still was
romantic
I was
lesson.
watching one of the videos only for relegation fighting the factor.
Why would you watch any of the
I watched the videos like 10 times for the
Okay, what's missing? If this was the answer, and the answer is a difference of squares,
2a
YouTube?
minus plus 5.
plus 5. Excellent.
Yeah.
Excellent, dude.
Ooh.
Who's up beside you, bro?
And look at this. We're done. But I don't have that worksheet because you have already got that factoring worksheet earlier. We've worked through it a bunch. You have homework on that page plus your pretest. But we are not going to work on that right now.
You're watching.